This is section 13.6, the fundamental identities. And this is going to be a section where you're going to be proving stuff and simplifying trigonometric expressions and transforming them to look like something else. How do we simplify trigonometric expressions and use them to prove identities? So basically this is a two-part lesson. First, we're going to simplify trigonometric expressions, and in the second part, we're going to prove identities using the tools and the expression simplifications that we learned in the first part of the lesson. And again, you need to be very familiar with all the different ways that trigonometric functions are expressed, and you're going to be using them a lot when we do these proofs. Let's first go over the trigonometric identities. An identity is true for all values of alpha, except when one side of the equation is undefined. So these are basically always going to be true for any angle, unless you have an undefined angle. There are three categories which we've all learned already. First, the reciprocal identities. Sine is 1 over cosecant, cosine is 1 over secant, tangent is 1 over cotangent, tangent is also sine over cosine. Cosecant is 1 over sine, secant is 1 over cosine, cotangent is 1 over tangent, cotangent is cosine over sine. When you put those together, you see that the reciprocals all multiplied equal to 1. So sine times cosecant is 1, cosine times secant is 1, tangent times cotangent is 1. So these are things you should all be familiar with by now. These are basically expressions of what they are when you multiply them together. Sine cosecant equal 1. Another thing we've already learned are the cofunctions. The sine of theta equals cosine of 90 degrees minus theta. If you go back to your right triangle, you will see that this is true if you use SOHCAHTOA. Cosine of theta is equal to sine of 90 degrees minus theta. Tangent and cotangent are cofunctions. Secant and cosecant are cofunctions. So if these come up in a proof or an expression you need to simplify, you know how to transform them. Finally, these are the Pythagorean identities. All three of these are based on the fact that sine squared plus cosine squared equals 1. Now, to get 1 plus tangent squared equals secant, all you do is divide everything by cosine squared. So sine squared divided by cosine squared is tangent squared. Cosine squared divided by cosine squared is 1. 1 divided by cosine squared is secant squared. To get from here to this third equation, you just divide all expressions by sine squared. So sine squared divided by sine squared is 1. Cosine squared divided by sine squared is cotangent squared. And 1 divided by sine squared is cosecant squared. Now, you will want to know these very, very well, because they are going to come in very handy when you do the proofs and when you simplify expressions. And again, you start with this one. If you forget these two, all you have to do is divide everything either by sine squared or cosine squared. Trigonometric identities are used to simplify trig expressions and to prove other identities. So let's see how this works. Example 1a. Simplify cosecant theta minus cosine theta cotangent theta. Alright, the way you want to basically do these is to re-express everything as a form of sine and cosine. So cosecant is equal to 1 over sine. Cosine you leave alone. Cotangent is equal to cosine over sine. Now what you want to do is combine these up here. So it's 1 over sine theta minus cosine squared over sine theta, which you can combine into one fraction. Now what you should be able to recognize, and you will need to very quickly, is what 1 minus cosine squared theta is. Well, that's equal to sine squared theta. So now you can rewrite the expression as sine squared over sine, and now you can simplify this to merely sine theta. So to simplify these expressions, you'll want to often express them in terms of sine and cosine, combine fractions, and then look for identities that are present in the fraction to simplify it even further. And once you get to this point, it's pretty simple. Okay, example 1b, 1 minus cotangent squared theta minus 1 over cosine squared theta. So use the strategies we used in 1a to try to simplify it, and then look for some identity that might help you reduce it even further. Alright, 1 over cosine squared theta is equal to tangent squared theta. So let's leave cosine squared theta right there. So sine squared theta over cosine squared theta is equal to tangent squared theta. So now we have a common denominator of cosine squared. So you combine them into one. Now, if you notice that you can convert sine squared theta minus 1 and make it the negative of 1 minus sine squared theta. If you do that, now you can change 1 minus sine squared theta into cosine squared theta. And now you can see that this is going to be negative 1. So what you want to do, again, is to simplify expressions using sine or cosine and try to combine them as best you can. Then what you're going to want to do is look for those trigonometric identities like sine squared theta plus cosine squared theta equals 1 or some variation of that equation. And then move things around, negate things if you need to do your best to simplify the expression. Go ahead and try example 1c, 1 minus cosine squared alpha over sine alpha cosine alpha. Again, use the same strategies we've used in parts A and B. Alright, 1 minus cosine squared is sine squared. So now what you can see is that you can reduce this fraction even further by dividing one of these sines into this sine squared. So after that canceled, you're left with sine alpha over cosine alpha, which is clearly equal to tangent alpha. So this one's more straightforward. Again, you need to identify that this is a Pythagorean identity and rewrite the equation correctly. 1d, cosecant t squared minus cosine t squared cotangent t squared. I will save you the effort and just say, hey, look at number 1, a, and see if you can change it. And if you do, you will see that you know that cosecant theta minus cosine theta cotangent theta is sine theta. Now all you have to do is plug in t squared, because when we were doing these identities, these are going to be true no matter what angle you put in unless it's undefined. So when you do these proofs, you don't have to say unless theta is undefined or unless t squared causes cosecant to be undefined. It's understood. So all you have to do is substitute t squared in for theta and write sine t squared. Notice the squared does not go here. If you put the square here, you're squaring sine. Here you're squaring the t. Example 2a, write secant theta in terms of sine theta. Alright, so what you're going to want to do here is to re-express secant in sine or cosine and then use the Pythagorean identity to substitute for cosine in terms of sine. So let's see how this looks. So first, secant theta is 1 over cosine theta. So what we're going to want to do is figure out what cosine theta is in terms of sine theta. Well, we know that sine squared plus cosine squared equals 1. So, therefore, cosine squared equals 1 minus sine squared. To find what cosine theta is, you have to take the square root of both sides. So when you do that, the cosine of theta equals plus or minus the square root of 1 minus sine squared theta. Now you will take this expression here and substitute it back into the original expression to get your answer. So, secant theta is equal to plus or minus 1 over the square root of 1 minus sine squared theta. You don't have to get rid of the radical in this expression because it's not looking for simplified radical form. It's not a number. Alright? So, again, solve for cosine using this Pythagorean identity, and then once you get it, substitute it back in. Now you can try 2b, write cotangent theta in terms of sine theta, and do the same thing that we went over in 2a. Alright, so there's your expression for cotangent, cosine over sine. We already figured out what cosine was on the previous slide, but for your amusement, here it is again. So cosine theta is plus or minus 1 minus a square root of 1 minus sine squared theta, and we just take this expression here and stick it up here. And there's our answer. Cotangent theta equals plus or minus the square root of 1 minus sine squared theta over sine theta. You can't really simplify that any further. Alright, general strategies for proving identities. These are found on page 637 of your book. So, what you're going to want to do is apply a strategy to solve problems like the ones on 3, 4, and 5. First, you're going to want to simplify the more complicated side of the identity until it's identical to the other side. So you'll see a proof. You'll generally want to start on the left because usually the left is the more complicated expression. Then you're going to use the strategies that we used in examples 1 to simplify it to try to get it to equal what's on the other side. The other possible approach is to take both sides of the equation and get them to meet somewhere in the middle. In other words, get them to equal the same thing. So you can take the expression on the left, get it to equal something. If you then take the expression on the right of the equal sign and get that to equal the same thing as what you got the left side to equal to, then you've also completed the proof. The big thing here, you can only work on one side of the equal sign. This is not an equation. You can not cross multiply. You must assume what's on the right is true. So what you can do is manipulate both sides to meet in the middle, or you just stick with one side and use strategies to simplify an expression. So here are some strategies. 1. You can express functions in terms of sines and cosines. So sometimes if you convert all the cotangents and tangents and secants and cosecants in terms of sines and cosines, it might make it easier to solve. Another strategy that you're going to use a lot is to see which Pythagorean identities can be applied. So, for example, the tangent squared plus 1 equals secant squared. 1 minus sine squared is cosine squared. There's also the cotangent squared plus 1 equals cosecant squared. So, if you see those or expressions using and based on those identities, that will go a long way. In other words, if you see a tangent squared, secant squared, sine squared, cosine squared, cosecant squared, cotangent squared, look to see if this is something that could work for you. Number 3, sometimes you're going to have to factor. So if you see a 1 plus cosine or 1 minus cosine x somewhere in the expression, you see a sine squared, this might be a clue that you might need a factor and something cancels out. You can also just factor out a single expression like you would factor out x from 3x squared plus 4x. 4, combine terms on each side of the identity into a single fraction. This means you can use a least common denominator and put them over a single common denominator. And lastly, you can multiply one side of the equation by an expression equal to 1. You cannot cross multiply. You cannot multiply the whole thing out and cancel a cosine squared on the denominator. You may only work one side of the equation. So that means you can write a fraction, then multiply the top and bottom of that fraction by the same thing, but you cannot multiply out a denominator. So let's see how this works. Okay, example 3. Prove that tangent squared plus cosine squared plus 1 over cosecant squared equals secant squared. So again, all you can do is work with the expression on the left. So we're going to start with this. You cannot touch the secant squared. You are trying to get this to simplify into secant squared. Alright, so let's use different strategies here. First thing you're going to want to do is convert things into sine and cosine. So tangent squared plus cosine squared plus sine squared equals what we started with, because we can convert 1 over cosecant squared to sine squared. Well, look at this. Cosine squared plus sine squared equals 1. Oh, look at this. Tangent squared plus 1 is secant squared. So in this case, you just had to convert this one into a sine squared. You didn't actually have to touch the other two. And if you notice that cosine squared plus sine squared is 1, then tangent squared plus 1 is secant squared, that made the proof very easy. Now, if you did it the longer way by converting these into fractions of sine and cosine, you would have gotten there. And there's more than one way to solve the problem. As long as you get from here to there, that's fine. But again, you cannot work on both sides of the equal sign. You can only work with this and do your best to get this side to equal to the right side. Alright, number 4. 1 plus cotangent squared over secant squared equals cotangent squared. Again, you're trying to get this to equal cotangent squared. Give this one a shot and check your answer when you're ready. Alright, so this is what you're starting with. Cotangent squared plus 1 is cosecant squared, if you remember that. Now, cosecant squared theta over secant squared theta happens to equal 1 over sine squared over 1 over cosine squared, which is equal to cosine squared over sine squared, which is equal to cotangent squared. So now you're done. Now, you might be able to recognize that this right away is cotangent squared, but just to be safe, I decided to do it a safer way by putting an additional step of converting cosecant to secant to sine and cosine, respectively. So again, work on only the left side to get to the thing on the right. Last one, number 5. Prove that secant beta cosecant beta equals tangent beta plus cotangent beta. Alright, now when I did this one, I basically took both sides, worked on them separately, and got them to equal to the same thing. You can do that too. So give that a shot and see how far you get. Alright, let's start with the left side. The left side, secant beta cosecant beta, I converted to 1 over cosine times 1 over sine by using the reciprocal identities. Combining that together, you get 1 over cosine sine b. Alright, I'm going to leave that one alone. Now, if I can get this side to equal this, I have proven the identity. So let's work on the right side. Tangent beta plus cotangent beta equals sine beta over cosine beta plus cosine beta over sine beta. I just re-express them as functions of sine and cosine. Now, let's combine them into one fraction by multiplying the top and bottom here by cosine, multiplying the top and bottom here by sine, so you have a common denominator of cosine beta sine beta. By doing that, you get sine squared beta, which would be here, plus cosine squared beta equals over cosine beta sine beta. Well, look at this. This is a Pythagorean identity. This is equal to 1. So, I've gotten the right side of the expression here to equal to this. Since I worked each side separately and got them to equal the same thing, therefore, this is true. Number 6. Cotangent squared phi minus cosine squared phi equals cotangent squared phi cosine squared phi. Try to do this one yourself. These are getting more difficult, but give this a try and see what you get. Look at the strategies on page 637 to see if any of them will be of help to you. Alright, so let's start with the thing on the left, and let's convert cotangent squared into cosine squared over sine squared. Now, what we can do is several things. You can have a common denominator. I decided to factor out the cosine squared phi. So cosine squared phi times 1 over sine squared phi minus 1 equals what we had before. Now, 1 over sine squared phi is equal to cosecant squared phi. So cosecant squared phi minus 1 times cosine squared phi is the same as the previous expression. Now, if you remember your Pythagorean identities, 1 plus cotangent is cosecant. So cosecant squared minus 1 equals cotangent squared. And now we have the same thing as we had on the right. We have proved our identity. So when you do these proofs, again, work on only one side of the equation and do what you can. You can factor, you can convert, you can rewrite. Do whatever it takes to get it to equal to the thing on the right. This is it for section 13.6. You're going to have a lot of practice doing this over the next couple days and tomorrow in class.